Okay, so this quadratic here, straight away we see that it has 3 unknowns, so we're given 3 equations. Okay, when this is the case, they're all linear equations, and we're not bringing in our linear and non-linear methods here. Okay, they're all given to us as linear equations. This one was actually really nice for 15 marks. Only if you really understand how we done the method of simultaneous equations when there was 3 unknowns. Okay, remember what we always done. Step 0 was we decided what was going to be the easiest way of getting 2 equations with only 2 unknowns. Okay, so usually we start by looking at these and saying what is going to be the easiest unknown for me to get rid of. If you spot it, we already have, so we always label these equations A, B, and C. Okay, equation C is already there with a variable gone. Okay, it already is there as an equation without y. So if you spot that, you can use A and B together to get rid of y, and then have 2 equations with 2 variables, just x and just z. If you manage to merge these to get equation D without y, you've got just x and z, and then you can merge it with this equation C. Okay, and have just x and z. Okay, I'm going to do it that way, and then I'm going to do it another way that a lot of people spotted, which was to just get rid of the z's and not even worry about the fact that there was no y here. Okay, that is also fine. It's just taking as long as they usually do, and this question was actually really nice because they gave you one of your equations to start off with. Usually we have to work with 2 equations to get to this point that they've already given us in C. Okay, so I'm going to do it out the nice quick way that you only could have done if you spotted that. Okay, so if you spotted there that we already have an equation that doesn't have y, then we could get rid of y from equation A and B together. Okay, so equation A, there was 2x. At this point, it is really important that you take down each equation exactly as they are in the question. Okay, just take a second to take them down fully correctly, because this question takes time, and if you take your time, if you put your time into this question and you've taken it down incorrectly at the start, then that is a huge missed opportunity, okay, from just taking down the question incorrectly. So if I want to get rid of my y's, okay, then I can multiply the top line by one thing. So let's say I multiply that by a -2. Okay, and I multiply the bottom line by another thing. So let's say 6. Okay, you guys told me that you prefer when they have the same number but opposite signs, so that you can add both lines. So that's why I'm multiplying by a minus here. And I don't know why I said 6 there. That should be a 3. Okay, so I'm multiplying by a minus here, so that one of them is going to be a -6y and the other one's going to be a +6y. Otherwise, we don't actually have to worry about the minus if we're happy to, if they have the same sign, to subtract one line from the other. Okay, but look, we're doing it this way. Okay, I'm going to multiply the top line by -2, so I get -4x -6y plus 2z is equal to, don't forget to multiply the other side, plus 8. Okay, equation B is now going to be 9x plus 6y plus 6z is equal to, and then 14 by 3 is 42. Okay, so now because they have the opposite signs, I can add the lines together. So, okay, so add my lines together. So I have a minus and a plus there. That's going to give me 5x. Then my y's are going to cancel. Here, I'm going to have plus 8z. And that's going to be equal to 50. Okay. So I'm in a really good position now because I can call that equation D. Okay, so equation D, it's one of my new equations. I'm going to label it myself, equation D. Okay, and I don't need to go and find another new equation with just x and z because they gave me an equation with just x and z. Okay, so I'm going to look at equation C and equation D together now. Okay, so equation C was x minus 3z is equal to minus 13. And then equation D was 5x plus 8z is equal to 50. Okay. So let's get the numbers in front of one of the variables the same but different. Okay, at this point here, I think I'm going to find it easier to get the numbers in front of the x's the same, equal but opposite signs. So to do that, I'm going to multiply equation C by minus 5. Okay, you could have gotten the coefficients of the z to have the same number with different signs, but then I have to multiply both lines across by something, which is still fine to do, but I'm just going to avoid doing that. Okay, so I'm going to multiply that by 5 so that I get, by minus 5, sorry, so that I get minus 5x plus 15z is equal to, and then plus 65. Okay, and then the bottom line is going to stay the same, so it's just still equation D. It's 5x plus 8z is equal to 50. Okay, so now I can add both lines together. So one nice clean line underneath them. So add both lines together so that the x's cancel, and I'm going to be left with 23z is equal to 115. Okay, so now I can find what z is. I don't want to start really working on that equation because I want the examiner to be able to see what 23z is. Okay, so I'm going to write it out again so that I can then do out the fact that I'm dividing it by 23, which means I have to divide the other side by 23, and then I'll be left with z by itself, which is going to be 5. Okay, then I go up to one of my fake original equations. Okay, so starting with just my junior cert part. Okay, so we're calling them original equations, but I'm putting quotation marks around it. Okay, not one of these originals except for C. Okay, purely because this is a different type of question where C was quite nice. So to get my original equation to find x, I go back up to where I started my junior cert method. I go back up to where I started the method with only 2 variables. Okay, so at this point here, I started just following my junior cert method. So I go up to one of those 2 original equations and I sub in for z in whichever one looks easier. Okay, in this case, because C was given to me in the question, I know there's no mistake. There's no silly mistakes whatsoever in equation C because it was given to me. Whereas D, there is a chance I made a silly mistake in that. So I'm going to use C. I know it's more likely to be a correct equation than D is. So I'm going to use equation C here. Okay, otherwise, if they were both just new and neither of them were given to me, then I'd just use whichever one I feel like looks easier. Okay, so I have x minus 3z is equal to minus 13. So I'm going to use that and sub in z as 5 so that I get x is minus 13 plus 15. So x is 2. Okay, now that I have my junior cert part solved, my 2 unknowns solved, now I go back to the leaving cert part, which is getting that 3rd variable. Okay, so I go up to one of my original equations, my actual original equations that were given to me in the question. If this moves, thank you. And I go up to one of these originals, okay, and I use it to find y. Okay, so obviously C isn't going to help me towards finding y, so I have to use A or B here, whichever one looks easier. Okay, so I'm going to use B. Okay, so I'm just going to have to take it down from here because I can't see the question, so apologies for that. But it's going to be, so it was 3x plus 2y plus 2z is equal to 14. And now I can sub in for x and for z. So x, I'm subbing in 2. I'm going to find y, I don't know how to sub it in, plus 2 times 5 is 14. Okay, so 2y then is going to be my 14 minus this 16. Okay, so 2y is minus 2, so I divide by 2 to get y by itself, and I get that y is minus 1. Okay, so that is my final answer. To just make it really, really clear to the examiner, okay, I can write my answers in the form x, comma, y, comma, z. Okay, so in this case, x was 2, y was minus 1, z was 5. Okay, another nice thing to do is put a box around them. Don't use red pen if you're putting a box around them. I shouldn't have even used red pen here doing that star for where we started the junior cert one. Okay, you don't want to use red pen at all. So this won't let me move. Once it does, you'll be able to see the full question. There we go. Okay, so there is our solution there.